So this video is going to go over the solution stoichiometry problem that you can find on your redox worksheet. I like to do this as kind of a review question before we take the test. So that's why I leave it to the very end. So iron 2 chloride reacts with acidified potassium dichromate. The iron 2 is oxidized, the chromium in the dichromate ion is reduced to chromium 3. You need to write a balanced redox reaction. So again, we have not done anything like this. This is just to kind of push you a little bit. So I would give it to you in this format. I would say the dichromate is becoming chromium 3. So that would be given to you, and then Fe2 plus is becoming Fe3 plus. The only thing that is important in that paragraph up there is it's acidified. So this is an acidic solution. So pause this video and then see if you could balance it, and then you're going to see my answer here in a second. So here is the balanced equation down here, and they add up to a plus 24 on either side. So the dichromate, the chromium is a plus 6 state in the dichromate, and it goes to plus 3. So the reason there are 6 electrons over here is the fact that there are 2 chromiums. So each chromium is essentially taking on 3 electrons. So that's why it is 6. And that is why this above equation needed to be multiplied by 6. So then the electrons cancel that way. And then you add everything up here on the bottom. And again, it doesn't matter the order. But you do need the balanced equation in order to do this part. On the test, I will not put a question like this specifically, because if you balance it wrong, this next part is going to be incorrect. So if it takes 26 mils of a 0.025 molar potassium dichromate to titrate 25 mils of an iron 2 chloride, what is the molar concentration of the iron 2 plus, and what is the molar concentration of the potassium ion after the titration? So a couple things. Titrate just means it is a way for us to slowly add one solution to the other and measure that. So titration doesn't necessarily mean acid-base. And secondly, molar concentration means molarity. So that's going to be a term that you're going to hear me use and also on the AP test. So what is the molar concentration of the Fe2 plus? Well, I don't have the concentration here, but I know how much potassium dichromate I added, and I have a relationship down here between the iron 2 plus and the dichromate. It's a 6-to-1 relationship, so I could use that to my advantage. So I'm going to take the 0.026 liters of the potassium dichromate and multiply it by the 0.025 molarity. And this is going to give me 6.5 times 10 to the negative 4th moles of potassium dichromate. Okay, so anytime you're given amount and then molarity, you could always find the moles of that substance. Well, if I look at that formula, the dichromate, I have one of those ions in this solution. So that must mean that is my 6.5 times the negative 4 moles of the dichromate. So I know for every dichromate, I have 6 irons. So I'm going to take the 6.5 times 10 to the negative 4 moles and multiply it by, I have 6 moles of Fe2 plus for every 1 mole of the dichromate from the balanced chemical equation. So again, like I said, you need a proper balanced equation to do the calculations correct. So I'm not going to put a question exactly like this on the test because it's going to be a nightmare to grade. So I end up with 3.9 times 10 to the negative 3rd moles of iron 2. So those are the moles. So my molarity is just going to be 3.9 times 10 to the negative 3rd moles. Okay. And my starting amount of the iron was 25 mils. So I'm going to divide that by 0.025 liters, which is going to give me 0.156 of iron 2 plus. Now, this was not given in the problem. But what is the amount of chloride in that solution? So again, I want you to think of the particle pictures we've been drawing and realize that I would have a +2 iron in there and 2 chlorides in that solution. So if this is the concentration of iron, 0.156, okay, if that's my concentration of iron, my concentration of chloride is going to be twice that. okay? So it's going to be 0.312 molarity. Again, that wasn't in the original question. I just used it as a review topic to help you through this. So the second part, part B here, what is the molar concentration of potassium ion after the titration? And the key word there is after the titration, right? So part B, I'm going to take the 6.5 times 10 to the negative fourth moles of the potassium dichromate. I calculated that already. Well, I know for every 2 moles in my in my molecule here of potassium dichromate, my ionic compound, I have 2 moles of potassium ion. So looking at the formula. So this is exactly what I did in the first part. I'm just showing it to you. So it's multiplied by 2 because I have twice the amount of potassium floating around in there as I do the dichromate. So what is the molarity of the potassium ion? Okay, so this is after the titration. We have a new volume now because with the titration, I'm adding one solution to the other. So that means I have started with 25 and 26 was added, okay? So I'm going to take 26 mils plus 25 mils, and that's 51 mils. So I'm going to take my moles of potassium and divide it by the new volume, which is 0.051 liters. So that gives you 0.0255 molarity for the potassium ion in solution. So if you go back to the original, okay, you would say that the concentration is 0.05 because you'd have twice the concentration here of the potassium as you do the dichromate. Problem is now that I have added a new solution to it, my concentration has gone down, and it should because you're essentially diluting it by adding something else to it. So I like this problem because it gives you a lot of flavors of things that you're going to see on the test.